Hi everyone, and welcome to today's AWS Tech Talk on how to experiment faster with low-code, no-code tools from AWS. Lots of great things to learn today, so I'm super glad you joined us. My name is Kosti Vasilakakis, and I lead the go-to-market strategy for AWS's machine learning service, which is also known by the name SageMaker. Today, I'm joined by my technical counterpart, Arun Shankar, who will help us with some really neat demos. Arun, how about a brief introduction to our audience?
Hi everyone, this is Arun Shankar. I'm a machine learning solutions architect with Amazon Web Services. My goal here at AWS is to enable customers with complex machine learning problems using the various set of capabilities provided by Amazon SageMaker and the different AI services within AWS. Welcome all.
Awesome. Thanks, Arun. So let's get right into it. As I said, quite a few things to learn today. By the end of today's sessions, we will make sure you know how to do the following three things. One, how to leverage a very simple drag and drop user interface to do data preparation and feature engineering for your machine learning problems. Two, how to tap into AWS's AutoML tool to build ML pipelines for your tabular data completely automatically. And three, how to leverage a set of pre-trained state-of-the-art models like GPT-2, Hugging Face, and ResNet for your natural language processing and computer vision use cases that will allow you to go from zero to hero in just a couple of minutes. Of course, we have a ton to cover today, and we'll run a little bit of a cooking show in some parts, but all the steps we will follow and the use case we will showcase are under this repo we showcase in the slide. github.com, Arun PRSH no code, low code. Go ahead and download the repo at your convenience, or go check it out as we speak. We will achieve these three learning objectives using this agenda. We will start with understanding why to even care about low-code, no-code capabilities. We will then talk about what low-code, no-code capabilities there are within the SageMaker umbrella, and what types of data and use cases you can leverage them. And then we will do deep dives in each capability while solving for three different use cases. Yes, we will build models for three use cases in the next hour. We will build a predictive model for tabular data, one sentiment analysis model for text, and one image classification model for what else? Images. So keep in mind that because we have lots of good things to cover, our Q&A runs throughout the session at the bottom of the screen. We're joined by many ML experts over the chat, so feel free to fire off your questions as they come up. Now, to level set, a typical ML workflow entails those four steps. You will have to start by preparing the dataset you want to train your model on. That involves lots of data exploration, cleaning, standardization, and feature engineering, and it usually is a quite tedious process to get it right. Then you will have to literally script one or more models, and then using the features you prepared, you'll have to provision infrastructure to train and tune those models usually using a cluster of machines, especially if you're talking about large data sets or use cases like text and images. Then you'll usually have to go through those steps multiple times to further optimize your pipeline with better features, additional types of models, or different hyperparameters. And then you'll have to use the best of those models, either live in your production environment or just in batch mode. However, as you understand and know from your own experience, this can be a very time-consuming process that requires tons of understanding and knowledge. Not only you have to have deep expertise in how to prepare your data in order to help your model the most to predict your target objective, but you will have to know which models to build or select and which hyperparameters to start with. To add to that complexity, Even really senior data scientists, like many of you here, go through those steps multiple times to find the ideal pipeline. And we have heard from our customers that data scientists are more than oversubscribed to projects. So many want to make your and their life a lot easier to ensure that you have the highest productivity you need to bring the best models you can in the fastest way possible to production. Now, come to the world of low code, no code machine learning, and many of those issues get completely alleviated. All of a sudden, customers say that they can prepare the features to train their models on in a matter of days instead of weeks. They also say that they can build, train, and tune hundreds of models in parallel completely automatically. And they state that with pre-trained models, they can reach production with a full-blown ML solution in a matter of weeks instead of months. Crazy, right? Well, I'm aware, but let's see what AWS tools can help you do exactly the same. There are 3 low-code, no-code capabilities within SageMaker. The first one is called SageMaker Data Wrangler, and it offers you a super easy visual interface with more than 300 pre-built data transformations that you can drag and drop into a flow, and with that create your feature engineering pipeline without writing a single line of code. Think of a single drag and drop, and all the feature engineering code is written for you. Super simple. Then the second capability is called Autopilot, and you can think of it as AWS's AutoML capability that you can give it a tabular dataset, and then it automatically creates a set of data preparation pipelines, develops different ML models, and considers a very big set of hyperparameters, and eventually gives you back the most optimal combination of all those. As you can see, even in the slide, Autopilot covers all the 3 steps of the ML workflow for your tabular datasets. And as Arun will show in a bit, you only have to select 4 items in the UI. And again, this is with 0 lines of code and just 4 items. And all this is taken care of for you. And lastly, the third capability is called JumpStart, and it has more than 300 pre-trained state-of-the-art models for computer vision and natural language processing, which you can use as is, or you can very quickly tune them using your own data. We call this technique, and it's very known as transfer learning, and you can tap into transfer learning with some simple UI right from JumpStart. Think of a set of advanced models like GPT-2, BERT, and ResNet that you can super quickly leverage or fine-tune in a matter of minutes. That's what JumpStart is. Now, let's see how we will dive deep in each one of those today. More specifically, we will solve for 3 different use cases. 1 for tabular data, 1 for text data, and 1 for images. In the first one, we will build a predictive model for loan defaults using tabular data from an open source loan dataset. In the second one, we will build a sentiment analysis model using text data from news. And in the third one, we will build an image classification model using images from Hurricane Harvey dataset, where we will try to predict if a building is damaged or not. So let's get going, and rest assured that we will give you a lot more details about each one of the use cases as we cover each one of them. For the first one, for example, the open source dataset that we will use is coming from Lending Club and contains complete loan data from all loans issued from 2007 to 2011, including the current loan status and latest payment information. In today's demo, we will first use Data Wrangler to do data exploratory analysis, as well as create a feature engineering pipeline with different transformations for you to see how quickly and easy it is to do complex feature engineering across numeric, categorical, and text columns in just a few clicks. And then we'll give those data to Autopilot that will do its magic to identify the most optimal combination of additional feature engineering, model, and hyperparameters for the lone default predictor. One thing to keep in mind here is that although Autopilot does its own feature engineering, we wanted to showcase a complete end-to-end use case that you can make your own feature engineering using Data Wrangler and then pass on the data set to Autopilot that takes care of adding more feature engineering. So in a way, you can use those tools completely separately and individually, and there is no need to always combine them. But here, we wanted to show you a nice story together. So let's start first with Data Wrangler and in a lot more depth how it works. This slide summarizes all the steps taken by SageMaker Data Wrangler. You can bring in to Data Wrangler data from a wide variety of data sources. You can leverage a set of pre-built visualizations to understand your data. You can tap into hundreds of data transformations to cleanse and enrich your data. And you can also estimate model accuracy or even understand if your data set has any issues like column leakage, and it helps you fix those. And once you're done with the process, you can either export the data in a completely ad hoc fashion, or you can also choose to operationalize the feature engineering workflow and ensure it runs at your predefined intervals in production. The key takeaway here is that these steps can be iterated in a whole or in part as you wish to very quickly build a strong set of data transformation code and features to improve the performance and quality of your machine learning models. I will add a bit more color to each one of those steps before we proceed with the first demo. Preparing high-quality training data often requires the collection of data in various formats from different data sources, which requires creating complex queries. With SageMaker Data Wrangler's data selection tool, you can quickly select data from several data sources such as Amazon Athena, Amazon Redshift, Lake Formation, S3, Feature Store, as well as data sources like Snowflake. And you can write queries for data sources and easily import those in various file formats such as CSV, Parquet, and database tables directly into SageMaker. And before importing large volumes of data from data sources, you can just query and inspect the data in the UI of Data Wrangler without actually consuming a lot of resources or time. In addition, Data Wrangler can help you intuitively understand your data with a set of robust pre-configured visualization templates, including histograms, scatter plots, boxes, whisper plots, line plots, and many more. Data Wrangler helps you interactively create and edit your own visualization so you can quickly detect outliers or extreme values. For example, you can select the histogram template, select columns of data to plot, and plot a histogram without writing a single line of code. Of course, if you want, you can build your own custom visualizations within Data Wrangler as well, as it supports Alterm for you to script with. Most importantly, though, Data Wrangler offers a rich selection of more than 300 pre-configured data transformations that you can drag and drop to your flow very, very quickly. In the transformations, you can find from single dropping or renaming of columns to imputing missing values for both categorical and numerical data, to curation of numerical datasets like normalization, standardizations, or to all the way to encoding categorical values with one-hot encodings, or even to creating embeddings for text. But also, you don't have those pre-configured transformations to play with. You can also write within Data Wrangler your own transformations using PySpark, SQL, or Pandas. So you have the flexibility to combine the out-of-the-box data transformations with your own transformations that you can quickly script. So if you see any transformation that is missing, do let us know, or in the interim, feel free to script it, and we're happy to include it as well. In addition, Data Wrangler enables you to quickly identify inconsistencies in your data preparation workflow and diagnose issues before your models are deployed into production. So you can select a subset of your data, validate your model against that data, identify possible errors, and determine which features are actually contributing to the model performance relative to other features. And that way you can determine what additional feature engineering you need to do so that you improve that performance. And all this is actually done before you deploying that model into production. This is a huge time saver for iteratively refining the features and improving model accuracy, all within the tool, without even reaching your model deployment. Finally, you can easily take code into production with Data Wrangler. Without manually sifting through and translating hundreds of lines of data preparation code, you can export your prepared data directly to S3, or you can export all your data preparation workflow directly to a notebook or code script with a single click for you to easily either to inspect it or to bring it into production. You can also integrate your data preparation workflow with SageMaker pipelines, which is our ML pipeline orchestration component, or any other open source ML pipeline orchestration framework like Kubeflow, Airflow that allows you to automate that model deployment and management. And importantly, you can also publish those features created by the pipeline in the SageMaker feature store for your future use and syndication across the organization. And all in all, Data Wrangler not only gives you a powerful set of data visualizations and data transformations, but it also gives you the capability to productionalize your workflows extremely quickly. Now, enough of me speaking. Time for you to see this for real. Arun, the floor is yours.
Kasti, thanks for the wonderful introduction to SageMaker Data Wrangler. Before we look into SageMaker Data Wrangler, let's talk about SageMaker Studio. So what is SageMaker Studio? SageMaker Studio is a fully integrated development environment for machine learning. So it provides a unified web-based visual interface where you can perform all your machine learning development steps in a very effective manner. So SageMaker Studio combines all of individual SageMaker's capabilities into one seamless experience. So let's see how to navigate to SageMaker Studio from AWS Management Console. So this is your management console. From here, click on SageMaker under AWS Services. So that takes you to the SageMaker console. So here you can see a SageMaker dashboard, and then also you can see a button to open SageMaker Studio. So once you click on that button, that should take you to the SageMaker Studio control panel, where you would see a list of your user profiles. So I've already set up SageMaker Studio with a user profile. So you can see the no-code, low-code workshop user profile. So I should be able to open Studio. So when I hit Open Studio, that basically opens up SageMaker Studio with the launcher. You can also see I've already cloned the workshop repository here. So let's navigate to the Tabular folder, where we'll be covering the first use case of lone default protection. All the steps that you need to set up SageMaker Studio, if it is the first time you're setting up SageMaker Studio, can be found in the repository under Setup Studio README file. Now, to summarize, SageMaker Data Wrangler is a very powerful visual interface that lets you do feature engineering, exploratory data analysis, data visualizations, and a lot more in a very effective manner. So let's see how to navigate to SageMaker Data Wrangler from the launcher. So from the launcher, you can see there's an option to create a new data flow. So let's click on that. Like as soon as you click on that, you can see SageMaker Data Wrangler is launching. So this will take a few minutes. So let's wait. Within a few seconds, you can see Data Wrangler is already launched. To verify that, you can go to the terminals and kernels icon here. You can see Data Wrangler under both instances and running apps. Now, in the workshop repository, you can see several notebooks. Like for example, you can click on the Explore Data notebook. You can look at the data as a pandas data frame. What we need to do now next is import some data from S3. So before that, let's go and rename this flow file, right, to lone default. So as you can see here, there's already a lone default file that's part of the repository. So you can either rename it to something else or delete it. So let's delete it and rename the untitled flow file, which we just created, to lone default. So next, let's go and import two pod files from S3. So there are other data sources from which you can input data. So you can also import data from Athena. You can also import data from Snowflake and Redshift. Let's go and import a data from S3. So from S3, go and choose the bucket and choose the folder where we have the pod files. So here, there's two pod files. Let's choose the first one. You can directly import after you take a look at the preview. Now let's go back to import and then import the other file too. So as you can see here, we have imported both the files. Now what we want to do with these two pod files is to combine them and get them ready, with all the feature columns we need to do analysis, to do transformations, to do some visualizations, all using Data Wrangler. So click on the plus symbol here on part 1 file. You can add join. As soon as you click join, you can see there's a left pane open up here. Click on the other block here for part 2 file, and then you can see there's a preview join that's converged. So now click on configure here. Give a name for your join dataset. So we're going to call it loans.csv. And then you can choose the different types of joins here. I'm going to choose inner join. And we'll be joining on the ID column. So both the pod files have the ID column. So let's go and choose ID for both left and right. And then apply. So as soon as I apply, you can see a preview of the joined dataset here. And then click add. So now what we have done is we have taken, the two pod files and combined it to one dataset. Now we're going to add a few transforms to make this data ready for feature engineering or analysis. So let's go and add transform. So under transform, what we want to do is we want to go and drop the ID columns. Because we did an inner join, there's going to be two ID columns with _0 and _1. So we want to drop both of these columns. Let's go and add a step here. You can see all the different types of transforms here. So we'll get into the type of transforms in detail. But here what we want to do is we want to go and manage columns, because we want to drop a column. So let's drop the ID 0 column. So you can preview, and then you can add that as a transform. So now you can always go back to your data flow here. As you can see, so we joined the data set, and then we made sure that we dropped the two written and ID columns, right? So we had true transforms added to this data set. Just ready now, let's see how to add analysis. So let's click on this plus symbol here and click add analysis. As you can see, under analysis type, there are a lot of different options for analysis. So you can look into bias in your data by choosing bias report. You can create visualizations out of the box. So you can choose histogram or scatter plot. You can also bring in your own custom visualizations, using Altar. So you can bring your own code and create custom visualizations. You can look into feature dependence by choosing multicollinearity. You can look at what features are not actually contributing to prediction using target leakage. You can also look at descriptive statistics by choosing table summary. For for the analysis type, let's choose quick model here, right? Let's cover that. For the rest of the analysis type, the step-by-step instructions in the repo has some instructions for you to follow and replicate. So let's choose quick model for now. So what quick model does is it really helps you create a model fast and then see what are the important features that are contributing to your predictions. Let's just name it quick model and then choose the label to be lone status and then hit preview. Is done training. You can see the feature attribution. So you can see the lone term was the most significant contributing feature towards prediction. So the quick model basically ran inference on the test set and got like 75% F score. So you can see the ranking or the feature attribution of all the different features here. So let's actually save this to the dashboard and let's get back to the data flow and start doing some feature engineering. So let's click on the plus symbol here, start with add transform. So the first transformation we're going to be doing is for numeric type data. So let's go and add step, scroll down, click process numeric. So here, the interest rate, for example, is a numeric feature type. So let's go and apply scaling, right? So there are different types of scalars which come in data Wrangler. So let's choose min-max scalar. And say we want to apply it on the interest rate column. So we want to normalize all the data between 0 and 1, preview, and add. So as you can see, as soon as you hit preview, this column is all normalized between 0 and 1. So we added that transform. Now let's go and add 2 more transforms. So the next one is going to be adding a feature transform for categorical column. So in this case, we're going to be applying it on the purpose column here. So let's encode categorical, change this to one hot encoding, and select purpose as the column we want to apply this transformation. The output style, we can choose it as vector. Again, preview. So as soon as you hit preview, you would see this column getting transformed to a vector. You can add that as a transform now. And then the last one we would be doing is for text column. So let's add a step, select featureize text, and then now we're going to be applying it for the employer title column, which is all text. Let's go and select the transform type to be vectorize, tokenizer as standard. We'll choose the token vectorizer. So you can leave the term frequency and document frequency as it is. You can change the vocabulary size to something smaller. Let's choose 1000. And then at the bottom, we need to select the input column. The input column is employee title. So once all this is selected, you can go and again hit preview. You can actually wait for that preview to happen. Or you can straight away go and add the transformation. So let's go back to the data flow. So for next step, we'll see how to export all these transforms or the the data set with the transforms directly to S3, and also other options for exporting. Export this join data set to an S3 location directly. Click on this plus symbol here, add transform, and here you should see an export data button. So click on that, and for the S3 location, let's give default location, hit export data. So you would see the data being exported to that S3 location in a few seconds to a minute. So let's go back to the data flow. So here you can see there's also an export tab here. So let's actually switch to the tab. So there is a direct way to export to S3, which we saw, but there's also other ways to export this data flow. Let's go and actually select all the individual steps we've done so far. So now we're saying, we want to export all the steps that we've captured in the data flow for different options. So here, the first option you see here is saving to S3, but then as a SageMaker processing job. So you can click on that, or you can export it out as a pipeline, or you can export it as a Python, Python script or Python code. You can also export, the output of this notebook to a feature store. So these are all different options for export. So let's click on Python code. So you can see, when you click on Python code, there's a lot of code in here. So this code basically, sums up all the different, transformations we have done so far. As you can see, there's hundreds or thousands of lines of code. And what Data Wrangler is letting you do is letting you kind of, circumvent that process of writing complex code and maintaining that code. Instead, you can go through the UI and then basically, recreate those steps easily through the UI. Now, the step-by-step instructions, right? I walked through you a lot of different steps. It's all captured under a README file, in the repo again. So you can go back to the repo and check this README file. So that concludes this demo. Kosti, over to you to talk about SageMaker Autopilot, which will come next. Thank you.
Awesome demo, Arun. Thank you. The amount of code that Data Wrangler produce when you just drag and drop visualizations and transformations is absolutely astonishing. Thousands of lines of code in a few minutes with a few clicks. That's why also customers like Deloitte are big proponents of Data Wrangler, because it helps them with feature engineering as they build models for their customers. And while the process before would take them months, with Data Wrangler now, it only takes a few days. That's a huge productivity saver. Now, before Arun helps us with the demo of Autopilot and the completion of the first use case, let's see how Autopilot actually works. As I mentioned, Amazon SageMaker Autopilots give you access to AutoML that makes machine learning easier and faster. You can build classification and regression models by just providing Autopilot with a tabular dataset and a target attribute. And that's it. It's that simple. Then Autopilot automatically analyzes your data like any data scientist would do, an exploratory data analysis, and then explores machine learning solutions with different combinations of data preprocessors, algorithm, and algorithm parameter settings to find for you the best model. So instead of requiring you to decide what feature engineering works best, which algorithm to use, or which are the hyperparameters that optimize the model, Autopilot automatically does that all for you with just a single click. In the end, Autopilot will present you with a leaderboard of the combinations it considered and will show the best performing models at the top. Then you can quickly select the best or any other candidate you prefer and deploy it with a simple click. Lastly, but very importantly, Autopilot is a fully white box experience. It not only gives you the performance metric of the best model, but it actually offers you all the code it runs for data preparation and all the code it runs for the model development and training for you to inspect or build upon it. In addition, it provides an explainability report that makes it easier for you to understand and explain how models created with SageMaker Autopilot make predictions. You can also identify how each attribute in your training data contributes to the predicted result as a percentage. The higher the percentage, the more strongly, of course, that feature impacts your model's predictions. Now, before we get into the demo, let's give a bit more details about Autopilot. As you can see from the screenshot, all Autopilot needs is an experiment name, a dataset, and a target variable. And then it takes care of everything else by itself. Everything else I covered before is taking care for you. Of course, there's advanced, for the advanced users out there, we offer additional controls around security like VPC, etc. And we give you controls around configuring further the number of candidate models Autopilot considers, which evaluation it should be basing the performance on. And quite importantly, everything that you see from the UI and every advanced configuration can be accessed via a simple API. So for the advanced users to programmatically trigger Autopilot jobs as they need. Then Autopilot, once you trigger that job, goes through the process I described before and gives you back a leaderboard of models to either leverage as is and deploy, or to better understand by seeing the explainability report or the code itself. And Arun will give us a lot more details there. But here, for example, you can see that you inspect the data exploration code or the candidate notebook that does the modeling. In either case, as you can tell, you have full control to edit the steps, add more transformers, change the algorithms, or even edit the hyperparameter agents that Autopilot considers. Of course, that's only to show the depth and flexibility of Autopilot and how much code it produces with you just giving a dataset and a target variable. You can still go with a very simple scenario of just using the best performing model and just call it a day. Simple as that. Now, without further ado, I'll pass it on to Arun that will walk us through the Autopilot demo and wrap up the first use case for us.
Thanks, Kasti. For this demo, we'll be looking at SageMaker Autopilot for the same use case of loan default prediction. So to get started, what we'll be doing in this demo is to take the output of demo 1. So in demo 1, we outputted a file to S3 using data Wrangler after we did all the transformations. So we're going to take that file and feed that as an input to an autopilot experiment. So let's see how to get started with an autopilot experiment. So from the launcher, click New Autopilot Experiment. So that brings us to the experiment setting. So here, all you need to do is just fill 4 fields. We also give you the flexibility to configure more fields, but for the sake of this demo, we wanted to keep it really simple and show you the fastest way to kick off an autopilot experiment. So for the experiment name, let's name it Loan Default Prediction. We can skip the option fields. For input data, let's enter an S3 bucket location. So I've already copied that S3 location. So this is the output of demo 1. So in demo 1, we use data Wrangler to do feature transformations. And at the end of it, we save these transformed features to a CSV file in S3. So we're using that CSV file location here. Choose the target column as loan status. For the output data location, choose enter S3 bucket location. Let's reuse that same S3 URI here. Instead of pod CSV, let's go and actually change this to loan default output. For the machine learning type, we're gonna keep it as auto. But if you know the machine learning problem type, prior to autopilot experimentations, then you can actually go and choose that. But let's keep it auto. For auto deploy, let's keep it as on. So we want to deploy the best model that's trained by autopilot as an endpoint. So let's keep that option and then name it Loan Default Prediction. Now hit experiment. So as you can see, as soon as you hit confirm, autopilot has kickstarted the experiment. So we have different stages of this experiment. So it starts with pre-processing. At this stage, it's going to look at your data, do data validations, do data splits. It's going to look into any missing, values in your feature columns. So a lot of things is happening, in the pre-processing stage. Then it gets to the candidate definitions stage, where it's going to be looking at what are the possible ways or strategies it can take to do feature engineering, right, on your input feature columns. So it's going to go and generate those different paths and gives you a notebook, right? So at the end of second stage, it gives you a notebook where you can go and actually look at these different candidate pipelines for feature engineering. So once, candidate definitions are generated, the next stage is actually, take those recipes, right? Or candidate definitions it has generated and actually do the feature engineering. So it's going to generate 10 candidates for feature engineering, and then it's going to basically, try executing those pipelines and generate, transformations on those input features. So past that stage, it's going to go and start doing model training and model tuning. And then once it trains all these different models concurrently, it's going to pick the best model and then deploy that model as a SageMaker endpoint. Finally, towards the end, it's going to take the best model and generate an explainability report for you to look at. So this usually takes less than 2 hours. So let's give it some time and then come back and look at, the results. All right. So after a couple of hours, you can see the autopilot experiment is complete. So you can see all the list of different models autopilot came up with. So the best model is obviously right at the top because these models are sorted by, the scores, the metric scores. So here we have 2 objective metric, so accuracy and F1 macro. So the best model is the one that has 83% accuracy and 33% F1 macro. So now let's click on the best model, right click, click open in model details.
So that's going to show you explainability aspects. So the explainability meaning here, we can see the feature importance. So which feature is contributing most towards the prediction. This is similar to what we saw with data Wrangler quick model. You can export this explainable report as a PDF document. You can also look at all the different artifacts. As you can see, the input data, shuffle, training and validation splits, transformed training and validation data, the feature engineering code. You can also go and grab the model, right? That's again in this S3 location. And then you can also look at all the explainability artifacts. So now let's go back to the finished experiment. So there are two options here right at the top. So you can actually look at all the different candidates. So let's click on this notebook here. So what Autopilot gives you is full transparency into what went behind the scenes, right? So we give you this notebook, meaning now you can look at all the different steps that actually happen to get to that optimal model. So you can look at like if you keep scrolling down, you can look at all the different candidate pipelines. So for example, if you look at this one, so this one used an XGBoost algorithm, and it's using robust computer for the numeric columns, and it's using threshold one hot encoder to transform the categorical. So it's a lot of information here. So every candidate is going to have a combination of certain feature engineering steps and a choice of algorithm. Similarly, you also have a second notebook that basically shows you, a little bit of data exploration, things like, how much of these columns were missing data, some, basic column analysis, right? Column statistics. So all the steps we talked about in this demo are captured in the workshop repository. So you can go here and look at SageMaker Autopilot on all the individual steps with screenshots. So that concludes this demo. Back to you, Kosti.
Thank you, Arun. So much code has been generated again by a low code, no code capability. And Arun only made 4 selections in the UI. I personally find it very fascinating and a huge time saver. Well, you shouldn't take my word for it though. We have many companies like RetentionX that tap into the benefits of Autopilot as they want to build many models at the same time in the most efficient way possible. In this case, RetentionX is a business insights tool for direct-to-consumer businesses and manages to build hundreds of different models for each one of their customers completely automatically so that they are able to offer them a fully personalized experience without having to really build one model manually per customer. So they tap into Autopilot to do all that heavy lifting for them for each one of the customers that they have. Well, that's what I call magic. Now, let's see the second use case, and more specifically, how you can use JumpStart's pre-trained models to build a sentiment classifier. As you know, companies have lots of unstructured data in forms, in documents. Also, they can tap into news, and at many times they're trying to make sense of them. One aspect of actually making sense of this is to understand the sentiment that those forms or documents or news have. And in today's demo, we will help you achieve this sentiment understanding by leveraging an open source data set from Financial Phrase Bank and using a pre-trained TensorFlow BERT model from JumpStart. So with just a few clicks, you will have your model ready for you to make sentiment classification. Before we get there though, and we understand this through the demo, let's understand a bit more what JumpStart is, what it does, and what models it entails. So think of SageMaker JumpStart as a model zoo of some of the best models you can find out there for computer vision and natural language processing. It includes more than 300 pre-trained open source models from hubs like PyTorch, TensorFlow, Hugging Face, and allows you to fulfill tasks like image classification, image embedding, object detection for all those for computer vision, and text generation, text classification, question answering, and sentence pairs classification for natural language processing. And you can access those powerful open source models like GPT-2, Roberta, BERT, ResNet, faster RCNN with just a few clicks. So either you use them as is for your models because they're pre-trained, or you can very, very quickly through a simple UI fine-tune them using your own dataset. And here you see that for one of the models, here we have ResNet 18, you can either just press the button to deploy it as is and use a pre-trained model, or you can choose to fine-tune it where you will bring your own data set and we can take care of running transfer learning for you in order to fully optimize this model based on your own data set. But all this is wonderful to hear, but a demo will make a lot more sense. So Arun, time to show our audience the JumpStart's magic.
Thanks, Kosti. Thanks for the introduction to SageMaker JumpStart. To reiterate, SageMaker JumpStart lets you quickly and easily get started with machine learning. On top of it, SageMaker also provides hundreds of the most popular state-of-the-art deep learning models for computer vision and natural language processing. So for this demo, we're going to be looking into an NLP use case. So let's jump straight into the demo. So from the workshop repository, under language, under new sentiment classification, you can see the data under data folder and also, a set of notebooks. So let's click on the Explore Data notebook. So the data set we're going to be looking into for this demo is Financial Phrase Bank data set. So it's basically got, two columns. So column, column headline contains news headlines, for the financial domain, and then on the other column, which is the label column, you got three classes for sentiment: negative, positive, and neutral. So it's pretty simple. Now, the goal of this demo is to use one of the different pre-trained models which SageMaker JumpStart offers for text classification, and see how we can classify this data set using one of those models. So to get to SageMaker JumpStart, let's click on this icon here, which is SageMaker JumpStart icon, and then click Browse JumpStart. So as soon as you click that icon, you can see the different options you have under SageMaker JumpStart. So let's go to the text models for now. So under text models, you've got 106 different pre-trained models that are ready to be deployed or fine-tuned, depending on what you want to do. So let's click on this option here. As you can see, we have several different models, trained using different frameworks, trained for different NLP tasks. So you have text classification, question answering, sentence pair classifications, text generation, summarization. So, trained using different frameworks. So you got Hugging Face, PyTorch, TensorFlow. So for this demo, because, we're doing text classification, let's go and type text classification and see what are the different options we have under text classification. See all these different options. So let's choose like one of this. Let's choose bird-based cased. So once you choose that model, pre-trained model, you can either deploy it straight away, or you can actually fine-tune it. If you want to take your data set, if you think it's custom, you want to actually fine-tune the pre-trained model. So it's basically a training job that you can run. So for our case, we're going to just straight away deploy this model for classification. So to do that, we got security and deployment options. So go and actually pick an instance type for hosting. So in this case, we're going to pick a CPU instance, so C5 2x large. You can also pick GPU instances if you want it, and then you can give it a name. So I'm going to call it news classifier. Security setting, you can just leave it to default. So once, all you need is these two options, right? And then it's just basically a single click. So once you click it, it's going to deploy that pre-trained model and create a RESTful API endpoint. So this will be a SageMaker endpoint, which you can basically invoke with your input news headline and get back a sentiment. So this is going to take a few minutes. So let's wait until that endpoint is up and active. Endpoint status as changed in service. So which means this endpoint is ready to be invoked with an input, and it should return the sentiment, as a response. You also see two other options. One that shows a demo notebook or a sample notebook on how to run inference using that endpoint, and then you have a delete option. So let's click on the open notebook. So this is basically showing inference code, which you can use as it is. But since we are using our own data set with 3 labels, so I have a slightly modified version of this code under make prediction notebook. So let's click on that. So here you would have to make sure the endpoint name corresponds to the one which is created. So I've already changed it to point to the one we created. So you make that change, and then basically you can run this notebook and see how to make inferences using that endpoint. So that concludes the demo, and back to you, Kasti.
Thanks, Arun. That was too easy. Well, I hope you guys saw the simplicity of using a pre-trained model. Now let's see how you can actually fine-tune one of them too. For this use case, we will focus on computer vision, and more specifically, we will aim to get into the shoes of Allstate and Farmers Insurance right after Hurricane Harvey. And they were trying to actually at that time predict very, very quickly which buildings in Southeast Texas were damaged or not, simply by seeing an image. And for this, we will use 1,000 images of damaged buildings and 1,000 images of not damaged buildings, and we will tap into the fine-tuning capability of JumpStart, where we will fine-tune a PyTorch ResNet 18 model. Arun, the floor is all yours for the last of the 4 demos.
So to get started, let's navigate to the workshop repository. So under Vision/Hurricane Damage Classification folder, you can see the data as well as a few notebooks. So let's click on the Explore Data notebook. So this notebook shows the images, right, under 2 classes, damaged, not damaged. And also towards the end, it lets you copy the data from local to S3. Let's copy this S3 location. We'll be using this when we're fine-tuning the model later to design the classifier. So let's copy this S3 location. Control C. So let's head back to SageMaker JumpStart. So click on this SageMaker JumpStart icon here, and then browse JumpStart. When you scroll down, you have text models, and then under that you have the vision models. So as you can see, we have over 200 models for vision. So let's click on the UL icon here. So there are several options here. You have CV models for image classification, object detection, semantic segmentation. You have models that lets you get the image embedding. So there are a lot of options here. So because we'll be doing image classification, let's go and type image classification quick here. That's going to list you all the different pre-trained models available for image classification. Let's pick the PyTorch ResNet 18 model here. So if you can remember in the previous demo, we didn't fine-tune the model when we were designing that NLP model for news headlines classification. So we basically took the pre-trained model, deployed it, and used it for classification. So here we're going to be fine-tuning the model on our custom data set, which is the images of the hurricane damage rooftop buildings. Let's go and actually change this to S3 bucket location, and then paste that S3 URL that we copied previously. For deployment configuration, we're going to choose the type of instance we're going to use for training. You can use GPU or CPU based instance. We're going to choose a P32X which is a GPU based instance. Model name, let's call it damage classifier. And for hyperparameters and security settings, we can leave it for defaults. So under hyperparameters, you can see epochs, learning rate, and batch size. So this should be optimal. So let's leave it to default and then hit train. So as soon as you hit train, now we're starting the fine-tuning process, right? So this training is going to take several minutes. So let's wait and come back and see what happens. A few minutes, you can see the training job is complete. So the fine-tuning process is complete. And if you scroll down, there's an option to deploy the fine-tuned model as an endpoint. So this would be a SageMaker endpoint, a RESTful API endpoint, which you can use to make the classification. So let's go and actually do that. Let's change a few parameters here. So let's change the hosting instance to a CPU based instance. Let's change it to C52X large and then give the endpoint a name. So let's call it damage classifier. And then for security seconds, you can stick to the defaults and then hit deploy. Now the deploy process again will take a few minutes because you're basically taking that model, preparing it, and then creating an endpoint. So let's wait for a few minutes. You can see the endpoint status has changed to in service, which means now you can use this endpoint to invoke the fine-tuned classifier to do classification on this building images. So you see other two options here. So one option is, this option provides you sample notebook code that shows how to do inference with that endpoint. And also you see an option to delete that endpoint. Let's click on this option here, open notebook. So you can see all the code that you need to do inference. So the repository contains, similar notebook with slight modifications. So you can use this notebook right in the repository to do actually, the classification. Make sure you change the endpoint name to the one which you created previously. So overall, what SageMaker JumpStart is providing you here, right? So it provides you with, a list of up-to-date, state-of-the-art computer vision models tailored for different downstream tasks, which you can use straight away, right? In a few clicks, you can go from, looking at a pre-trained model to having a real-time endpoint that you can leverage to make predictions. So JumpStart makes it really easy to do computer vision. So that's the whole idea here.
That's exactly the idea, Arun, indeed. Absolutely. JumpStart is a game changer for customers doing natural language processing and computer vision, as they get access to more than 300 state-of-the-art models with a few clicks. My Case, for example, offers a powerful legal practice management software that helps firms run efficiently from anywhere, and they use machine learning to help with core business and product challenges. But for many years, they struggled with launching end-to-end solutions. However, they discovered SageMaker JumpStart, and My Case now has better starting points, which makes it so easy for them to deploy an ML solution for their own use cases in between 4 to 6 weeks instead of 3 to 4 months that it used to take before. That's a huge productivity improvement. And just before we wrap up, here's 3 things you can do right now. First, continue asking questions at the Q&A box below. We will definitely stick around. Secondly, go to Arun's repo shown here to do exactly what's showcased at your showcased in the demos at your own pace and your own convenience. Script it now, take a screenshot. Here it is for you to use it as you wish. And thirdly, yet extremely importantly, feel free to reach out to our AWS ML expert via this email. It's low-code, no-code ML at amazon.com. And that leaves me to say a very big thank you from me and Arun to all of you that attended the session. Hopefully, we at least got you excited about the power of AWS's low-code, no-code capabilities, and we're looking forward for you to test these out and give us feedback. Hope you have a great rest of the day, and we can't wait to hear from you. Thank you very much.